It's time now for a new topic. We want to talk about the definite integral. We've learned that the indefinite integral is an antiderivative. There is a connection between the definite and the indefinite, which I hope to develop in this video. So I've loaded this with more stuff than usual because there's a lot of drawings and notation here. I've made the notation that the definite integral is an area, and that is a very usual and a very useful interpretation of the definite integral. We'll find some other ways to look at it, but this is where we want to start. So suppose that I have a function f of x, and I've picked one that's going to work well for us, 0.75x plus 31 over 4. That's f of x, and that's this orange line right through here. And I want to take the definite integral, and definite integrals have starting places and stopping places. Here's a symbol for the definite integral of f of x dx. And this is called the lower limit of integration. The 3 is the lower limit of integration. The 12 is the upper limit of integration. That means that I'm going to accumulate the area underneath f of x between 3 on the left, the lower limit, and 12 on the right, the upper limit. I've picked this particular function because we can easily see what the answer should be. That is, we can calculate the area underneath this orange line. I may call it a curve because in the most general sense a line is a curve. Underneath the orange line or curve above the horizontal axis and between 3 on the left and 12 on the right. And if we wanted to calculate that area, I would just take this geometric region and make two regions out of it. One is a rectangle, that's easy to calculate the area of, and the other is a triangle, and that's easy to calculate the area of. And so I see that this is 310, so this horizontal line would go to 10, and I've got A area is equal to the area of the rectangle. It's going to be 3 to 12 or 9 units wide plus 10 units tall, and then all I need to do is to add on top of that, I don't know what I said here, but that would be multiplication. Add on top of that the area of the triangle, and triangles are always 1/2 the base, which would be 9, times the altitude or height. And here's a point 10, and here's a point 16.75, so this would be a 6.75, and that is what I would just call a calculator problem. And the result will be 120.375 square units. And we're not so concerned about the units here because this is not a story problem. It doesn't have a background application. Now that's just there for reference. So let's look again at the symbol for the definite integral. It's the definite integral between 3 and 12 of the function f of x dx. And in this next notation, I've replaced the f of x, the general placeholder, by what this particular function is, 0.75x plus 31 over 4 dx. And now I want to show you how to evaluate a definite integral. And this is the connection between the definite and the indefinite integral. You take any antiderivative, and you evaluate it between the lower limit and the upper limit. And this is a notation, the straight line. I think we've used it in a different context before, but it means whatever this expression turns out to be, evaluate it at the upper limit, that would be 12, and subtract what you get when you evaluate it at the lower limit, which would be 3. So let's see how this works out. Here's my function, so I need any antiderivative. And we know how to take antiderivatives of the simpler functions. So this would be 0.75 x squared over 2 plus 31 over 4 x. Now, that's an antiderivative. I'm going to take the constant c just to be 0. Since it's any antiderivative, I might as well take the simplest one with that constant equal to 0. And then I'm going to evaluate that between 3 and 12. And let me scroll just a tad. By evaluating, I mean plugging in values. So this would be 0.75 over 2, upper limit 12 squared, plus 31 over 4, and there's another x, and so I put in the upper limit again, 12. That's what I get when I evaluate the expression at the upper limit. Now I have to subtract off what I get when I evaluate the expression at the lower limit. So that would be 0.75 over 2, 3 squared, plus 31 over 4 times another x to be replaced by 3. Now I've evaluated the expression at the upper limit, and I've evaluated the expression at the lower limit. I do all this arithmetic, take the difference, and you can of course verify this on your own, but you would get 120.375. So now we've evaluated our first definite integral, and you see the interpretation of an area, well, that works out exactly right. Now, we're interested in much broader areas than just geometric figures that are easy to calculate by other methods. So we'll find applications of the definite integral in subsequent videos. Thank you.